First question, when a disk rotates with uniform angular velocity, which of the following is not true? The sense of rotation remains same. The orientation of the axis of rotation remains same. The speed of rotation is non-zero and remains same, or the angular acceleration is non-zero and remains same. So first of all, we know that the rate of change of angular velocity is defined as angular acceleration. If particle has angular velocity, suppose omega 1 at time t1 and angular velocity of omega 2 at time t2, then the angular acceleration is equals to omega 2 minus omega 1 the whole upon t2 minus t1. Now when the disk is rotated with constant angular velocity, angular acceleration of the disk is 0, because we know that angular acceleration is alpha is equals to change in omega upon change in t, where here omega is constant, so the change will be equals to 0. So correct answer for this question is option D, that angular acceleration is non-zero and remains same. Correct answer for this question is option D. Moving towards the next question. For which of the following does the center of mass lie outside the body? Okay, so center of mass is a point that moves as though all the mass were concentrated there and all external forces were applied there. Important point about the center of mass is the first, the position of the center of mass is independent of the coordinate system chosen. Second, the position of the center of mass depends upon the shape of the body and distribution of mass. Third, we can imagine a rigid body also as a system of masses, and hence every rigid body has a center of mass. In case of an irregularly shaped uniform rigid body, center of mass is simply the geometric center of the body. Now a bangle is in the form of a ring, as we know that the position of center of mass depends upon the shape of the body and distribution of mass. So out of the four given bodies, that is pencil, shot put, dice and bangle, the center of mass lies at the center, which is outside the body. Whereas in all other three bodies, it lies within the body because they are completely solid. So correct answer is option D, that is a bangle. Looking towards the next question. A uniform square plate has a small piece Q of an irregular shape removed and glued to the center of plate, leaving a hole behind in figure. The moment of inertia about the z-axis is then. So in the given diagram, when the small piece Q is removed and glued to the center of the plate, the mass comes closer to the z-axis. Hence, moment of inertia decreases. So correct answer for this question is option B, decreases. Looking towards the next question. A merry-go-round made of a ring-like platform of radius r and mass m is revolving with angular speed omega. A person of mass m is standing on it. At one instant, the person jumps off the round radially away from the center of the round. The speed of the round afterwards is. So as no torque is exerted by the person jumping radially away from the center of the round, let the total moment of inertia of the system is 2I. That is round plus the person, because the total mass is 2m. And the round is revolving with angular speed omega. Since the angular momentum of the person when it jumps off the round is 1 omega, the actual momentum of the round seen from ground is 2I omega minus I omega, which is nothing but equals to I omega. So we conclude that the angular speed remains same, that is the omega. So correct answer for this question is option B. Looking towards the last question, which of the following point is likely position of hollow of the center of mass of the system as shown in the figure? So the position of center of mass of system in this problem is closer to the heavier mass or the masses, or we can say that it depends upon the distribution of mass. So it is likely to be at point C, that is here. In the above diagram, the lower part of the sphere containing sand is more heavier than the upper part containing air. Hence, center of mass of the system lies below the horizontal diameter. So, correct answer for this question is C. So, option C.